Aerial application is a job that demands precision, resilience, and constant vigilance, and sometimes even that isn't enough. In this video, we will examine the fatal crash of an air tractor AT-602 near Oxford, Indiana on July 22, 2024. Through a factual breakdown of the aircraft, pilot background, flight details, and early investigative findings, we'll explore how a routine crop spraying mission turned tragic in seconds. The goal here isn't speculation, but understanding what we know so far, what might have contributed, and what lessons might emerge from a profession where risk is part of the job. Now let's dive in to see what happened. The aircraft, registration November 602 Whiskey Romeo, a robust single-engine turboprop designed for crop dusting, bore the manufacturer's serial number 6021195 and was built in 2010 by Air Tractor Inc., a Texas-based company renowned for its rugged ag planes. Operated by Bi-State Air Inc., based in Petersburg, Indiana, this particular AT-602 was a workhorse, purpose-built for low-altitude spraying missions under 14 Code of Federal Regulations, Part 137. With its wide wingspan and powerful Pratt & Whitney Canada PT-6A engine, the AT-602 is a staple in the agricultural aviation industry, capable of carrying substantial loads of liquid or granular applicants to treat vast fields efficiently. On that fateful evening, November 602, Whiskey Romeo was loaded with a full hopper of liquid applicant and fueled for a routine mission, underscoring the demanding nature of its role in supporting Indiana's agricultural heartland. At the controls was Robert Ray Cottingham, a 35-year-old pilot whose passion for aviation was as deep-rooted as the crops he tended from the air. A resident of rural Otterbein, Indiana, Cottingham was no novice to the skies. Armed with a bachelor's degree in agricultural business management from Purdue University, he blended academic rigor with a lifelong fascination for flight, sparked by visits to the Oshkosh Air Venture, the world's premier aviation gathering. His career began taking shape during college when he started flying, initially cutting his teeth with AgriFlight in Wakarusa before joining Bi-State Air in Attica, Indiana. Cottingham's experience spanned both piston and turbine-powered aircraft, equipping him with the skills to navigate the unique challenges of agricultural spraying, missions that demand precision, quick decision-making, and nerves of steel. His journey from a Purdue graduate to a seasoned ag pilot reflects the dedication and grit required to thrive in this niche but vital sector of aviation. The flight's purpose was straightforward yet inherently perilous: an aerial application mission to spray 2 fields near Oxford, Indiana. Operating under Part 137 regulations, which govern agricultural aviation, Cottingham's task was to apply liquid applicant to crops, ensuring even coverage to protect yields in a region where farming is a way of life. The mission began at Riley Field Airport, a small private airstrip in Attica, Indiana, serving as Bi-State Air's base of operations. At approximately 5:40 p.m. Eastern Daylight Time, November 602, Whiskey Romeo lifted off with full fuel tanks, its hopper brimming with the chemical load needed for the job. The flight plan was simple: depart Riley Field, treat the designated fields, and return to base. Yet as the sun began its descent over the Indiana plains, this routine operation would take a devastating turn, setting the stage for a sequence of events that would end in tragedy just under an hour later. With full fuel tanks and a hopper loaded with liquid applicant, the aircraft was primed for its aerial application task over 2 fields near Oxford, Indiana. GPS data paints a clear picture of the flight's early moments. After takeoff, the airplane tracked north, covering the short distance to the target fields with the efficiency of a machine built for precision. The Indiana landscape below, a patchwork of soybean and cornfields, basked in the golden light of a clear summer evening, with weather conditions near perfect: 10 miles of visibility, a light 4-knot breeze from 290 degrees, and a balmy 27 degrees Celsius. Yet, within this serene setting, the seeds of a tragedy were sown as the flight's final minutes unfolded with devastating swiftness. 11 minutes into the flight, at approximately 5:52 p.m., Cottingham began spraying the 2 designated fields, executing the low-altitude passes that define agricultural aviation. The AT-602, flying at altitudes between 50 and 100 feet above ground level, completed 2 spray passes with the precision demanded by the task. The pilot's focus would have been intense, juggling the aircraft's flight path, the spray system's operation, and the GPS-guided navigation that ensures even crop coverage. The final recorded GPS track captures the critical moment. Cottingham was performing a west-to-east trim pass along the southern edge of the northern field, a maneuver designed to tidy up the edges of the spray pattern. This low-altitude pass, likely at the lower end of the operational envelope, left little margin for error, a reality that underscores the inherent risks of ag flying, where pilots operate at the razor's edge of aerodynamics and terrain. At 6:30 p.m., just under an hour after takeoff, the flight ended in catastrophe. The AT-602 crashed in a soybean field 0.45 nautical miles east of the field being sprayed, its final resting place marked by a crumpled airframe oriented on a 137-degree heading. The aircraft impacted inverted, a detail that hints at a sudden and uncontrolled descent. A post-impact fire flared briefly in the aft engine compartment but was swiftly extinguished by first responders, limiting fire damage to that area. The wreckage told a story of concentrated devastation. There was no debris path or crop disturbance leading to the site, suggesting the airplane did not suffer an in-flight breakup or prolonged loss of control before impact. All components remained in the immediate vicinity, a testament to the abruptness of the crash. The propeller, partially buried in the soil, bore telltale signs of power at impact. Its blades exhibited compound bending and twisting, consistent with the engine producing thrust right up to the moment of collision. Examination of the wreckage revealed critical details that deepened the mystery of the crash. The flap actuator, found intact, was extended to a position indicating full flap deflection, a configuration typical for low-speed, high-lift maneuvers like trim passes, but one that increases stall risk if mishandled. Flight controls, despite overload separations from the violent ground impact, were traced from the cockpit to the control surfaces, showing no obvious pre-impact failures. The engine remained attached to its mount, though the mount itself was heavily damaged. Weather, as recorded at Purdue University Airport 16 nautical miles away, posed no hazards. Clear skies and calm winds offered no meteorological clues to explain the loss. Maintenance records further complicate the puzzle. A 100-hour inspection completed just 4 days prior, on July 18th, showed the aircraft had logged 41.9 hours since, with no unresolved discrepancies. The outcome was stark. Cottingham, the sole occupant, was fatally injured, and the AT-602 was destroyed, leaving investigators to piece together the chain of events that turned a routine spray mission into a tragedy. Okay, now, let's dive into the details to see if there's anything we can learn from this. The NTSB's preliminary report gives us some solid clues, but since their final report isn't out yet, we're piecing things together carefully. No jumping to conclusions here. This is about exploring the factors that could have turned a routine crop-spraying flight into a tragedy. So, let's walk through the possibilities based on what we know and see how they might have come together. First off, this plane was flying low, really low. The report says it was at about 50 to 100 feet above the ground during its final pass. Now that's a bit higher than the 10 to 30 feet ag pilots often hit when they're spraying, but it's still crazy close to the dirt. At that altitude, there's no room for mistakes. A gust of wind, a twitch of the controls, or something throwing the plane off balance, you've got maybe a second to react before you're in trouble. The report notes there's no trail of debris or torn-up crops leading to the crash site, so whatever happened, it was sudden. The plane just dropped. That low-altitude game is the reality of crop dusting. It's high stakes, and it might have set the stage for whatever went wrong. Now, let's talk about the flaps. The wreckage showed the flap actuator was locked in at full extension. Full flaps, in other words. For those not in the aviation world, flaps are like extra lift generators on the wings, perfect for flying slow and steady over fields to get that spray just right. But here's the catch. Full flaps also make the plane more likely to stall, especially if something like a wind shift or a quick turn pushes it too far. The plane hit the ground upside down, which makes you wonder if it rolled or stalled out in a way the pilot couldn't catch. Those flaps were doing their job for the mission, but they might have made the plane a bit too twitchy at the wrong moment. Then there's the pilot's side of things. Flying a crop duster isn't just piloting, it's like juggling while riding a unicycle. You're steering at treetop level, tweaking the spray system, dodging power lines, and following a GPS to nail the pattern. That's a ton to handle, and it's easy to imagine the pilot, Robert Cottingham, being stretched thin. On top of that, this crash happened at 6:30 p.m., with the sun getting low. Picture that glare bouncing off a soybean field. It could have made it tough to judge the ground or the plane's attitude. We don't know if that's exactly what happened, but that kind of workload and visual challenge could have left the pilot a split second short of catching a problem. Could something mechanical have tripped things up? The plane was in good shape. Maintenance records show a 100-hour check just 4 days before, and nothing was flagged as broken. The propeller was bent and twisted, telling us the engine was still churning out power when it hit. So, no engine failure here. But there's still a chance something sneaky, like a glitch in the controls or a weird spray system issue, could have thrown the plane off. Maybe even turbulence from an earlier pass stirred things up. The report doesn't point to anything specific yet, but we can't rule out a small mechanical or aerodynamic gremlin until the NTSB digs deeper. And here's the kicker. At 50 to 100 feet, there's just no time to recover. If the plane stalled, rolled, or spun, whatever it was too close to the ground to pull out. That upside-down impact screams a fast, out-of-control drop, and at that height, you're out of options. That's the brutal truth of flying this low. So, wrapping this up, the NTSB's early info points to a mix of things that might have stacked up. The super low altitude, those full flaps tweaking the plane's handling, the pilot juggling a ton of tasks under tough visual conditions, and maybe a mechanical or aerodynamic hiccup we don't know about yet. These are just possibilities, not the final word. We're waiting on the NTSB to nail it down. For now, it's a sobering look at how crop dusting, where every flight pushes the edge, can go from routine to tragic in a heartbeat. Under the wide, sunlit skies of central Washington, crop dusters fly just feet above the earth, precise, relentless, and often unnoticed. These aerial applicators are experts in a field where the margin for error is razor thin, and the work leaves no room for hesitation. Among them was Gavin Morse, a veteran pilot and co-owner of Gemtrek LLC with over 7,000 hours in the air, 5,000 of those in the very aircraft he flew that day. But experience, as this story reveals, is not always enough to escape the unforgiving laws of flight. A master of his craft, flying a mission he'd completed countless times before, fell victim to a mistake so subtle yet so final. Here's what happened. The aircraft, a 1996 air tractor AT-602, registration November 602, Golf Hotel, was purpose-built for the demanding job of aerial application. With a restricted category airworthiness certificate, this plane was designed for agricultural spraying under FAR Part 137, a type of commercial operation that doesn't typically require a filed flight plan, and the mission was spraying pesticides over a designated farm field near Lind, Washington. This wasn't Gavin's first time flying this mission, nor was it new terrain. At 38 years old, he had built a career that stretched across the U.S. and even internationally, working with firms such as Royal Flying Service, B&R Aerial Crop Care, and Fender Flying Service. With a commercial pilot certificate and a valid second-class medical certificate, he was fully qualified to operate that day's flight. Despite not holding an instrument rating, a common trait among crop dusters who fly strictly visual missions, his deep familiarity with both the aircraft and the region made him a trusted figure. On July 2, 2022, Gavin embarked on another routine operation, departing from his hangar just after refueling and reloading the aircraft's hopper. The objective was clear: apply pesticide over a nearby field using a low-altitude, methodical racetrack pattern. No flight plan was required, and none was filed, which is standard procedure in this line of work. However, what began as another day in the skies over Grant County would end in tragedy just 16 minutes after takeoff. So, what happened? It was around 5:17 p.m. Pacific Daylight Time when Gavin Morse took off above Warden, Washington. The air tractor AT-602, loaded with pesticide and fueled for another short-range agricultural mission, lifted off without incident. As with countless previous flights, Gavin followed the familiar racetrack pattern typical of aerial spraying, low-level passes from west to east across the crop field. These low-altitude flights demand acute situational awareness, sharp reflexes, and complete confidence in both pilot and machine. There is little margin for error when flying mere feet above treetops, wires, and terrain. For Gavin, this was not new. His deep experience made him comfortable navigating such environments. But comfort, even experience, can sometimes conceal subtle risks. Just 16 minutes into the flight, the routine became anything but. Surveillance footage from a building about a mile away captured the aircraft flying wings level, steady, stable. Then came a steep right turn, a maneuver likely intended to reverse course and continue the spraying pattern. Yet within just 7 seconds, that maneuver unraveled into catastrophe. The aircraft pitched sharply nose down, the right wing dropping low as it descended behind a low hill. Then, silence. A rising plume of dust was the only sign that something had gone terribly wrong. The wreckage was found roughly 4.5 nautical miles east of the departure point, resting in an open field. Despite the violent descent, the airplane impacted the ground in a nearly flat and upright attitude, suggesting that Gavin had not entirely lost control. There was no fire, but the scent of Jet A fuel lingered in the air. The debris field extended about 190 feet, and all major components of the aircraft were accounted for, confined within this area. So what happened here was not an in-flight breakup or mechanical explosion, it was a hard, unforgiving impact. This was a bright, calm afternoon in eastern Washington, and it ended with the loss of an experienced pilot, a husband, and a business owner in a profession where risk is part of the job, but tragedy never routine. Post-accident examination told a clear mechanical story. The engine, a Pratt & Whitney PT6A65AG turboprop, was generating high power at the time of impact. Flight control continuity was confirmed from the cockpit to all surfaces. There were no signs of pre-crash mechanical failure. The aircraft was, by all technical accounts, performing as expected, and that is what makes this accident so painful, because it wasn't the machine that failed. So the real question here should focus on the pilot. How does an experienced pilot, someone with thousands of hours in the same aircraft, end up in a fatal crash on a routine flight? How can something so familiar, so practiced, go so suddenly and irreversibly wrong? The short answer is this: aerodynamics doesn't care how many hours are in your logbook. The longer answer lies in the specific maneuver that brought Gavin Morse's flight to its tragic end. According to the NTSB, the crash occurred because the pilot exceeded the critical angle of attack during a steep turn. That exceeded angle led to a classic but deadly result, an aerodynamic stall. And because the aircraft was flying low, as is standard in crop dusting operations, there was no altitude left to recover. Let's unpack that. The angle of attack is one of the most fundamental concepts in flight. It's the angle between the wing's chord line and the oncoming airflow. In simple terms, it's how tilted the wing is relative to the air it's slicing through. Increase it too much, and the smooth airflow over the wing breaks up. The wing stops generating lift. That's called a stall. It's not a problem exclusive to new pilots. It's a risk that can catch even the best off guard, especially when maneuvering aggressively. Now imagine an aircraft like the air tractor AT-602, a powerful single-seat machine designed to fly low and fast while carrying heavy loads of pesticide or fertilizer. When that aircraft makes a steep, tight turn, the forces acting on it increase dramatically. The wings are suddenly under more pressure to maintain lift. To compensate, the pilot naturally pulls back, raising the angle of attack. But if they pull just a bit too much, even for a moment, the critical threshold is crossed. The wings stop flying, the plane drops, and that's precisely what happened to Gavin Morse. He was likely executing a tight reversal turn, part of the racetrack pattern used in spraying fields. Surveillance video showed the aircraft flying level before entering a sharp right turn. Within just 7 seconds, the plane nosed over and dropped out of the sky. There was no fire, no in-flight breakup, no engine failure. In fact, the engine was operating at high power at the moment of impact. Flight controls were intact, weather was clear. The only failure was aerodynamic. The wing stalled and gravity did the rest. And yet, this wasn't the mistake of a careless rookie. Gavin had over 7,000 total flight hours, including 5,000 hours in the AT-602. He was co-owner of his own agricultural aviation company. He knew the aircraft, he knew the field, he knew the mission. But sometimes, when you've flown the same field 100 times, familiarity can blur the edge of risk. You know your aircraft, you trust your instincts, and that trust can cause you to push the envelope, not recklessly, but subtly, almost imperceptibly. Maybe the turn was just a little too steep, maybe the airspeed dipped slightly, maybe the load shifted a bit in the hopper. Alone, any one of those things might not matter, but together they create a situation where a stall becomes not just possible, but inevitable. And tragically, there was no altitude left to fix it. This exact scenario has played out before. In May 2019, a veteran pilot flying an air tractor AT-602B crashed during a crop dusting run near Silverton, Texas. Like Gavin, he was highly experienced, over 9,000 hours in the air. Like Gavin, he entered a steep, low-altitude turn. And like Gavin, he stalled and crashed before he could recover. The NTSB reached the same conclusion. The pilot exceeded the angle of attack during a turn at too low an altitude. The similarities are unsettling. 2 veteran pilots, 2 air tractors, 2 low-altitude turns, 2 stalls, no second chances. One might ask, why such a steep turn? It could be operational. Tight turns save time and reduce overlap in pesticide application. Or perhaps it was simply a byproduct of repetition, a pattern flown hundreds of times before without incident. We wouldn't have a chance to know the real reason, but on this day, it was proved a fatal decision. So what can be done? Many modern aircraft, particularly those used in training or commercial airline operations, are equipped with angle of attack indicators. These devices give pilots real-time visual cues when they're approaching stall conditions, even if everything else feels normal. In agricultural aviation, however, such instruments are not standard. Pilots often rely solely on instinct and feel. Would an angle of attack indicator have saved Gavin Morse? It's impossible to say with certainty, but it may have given him an early warning, just enough to ease the turn, lower the nose, regain lift, just enough to avoid becoming another statistic. Then there's the issue of industry training and culture. Agricultural pilots face a unique set of pressures: cover more acres, fly more loads, finish before the wind picks up or the light fades. That pressure can push even seasoned pilots into flying more aggressively, taking tighter turns, cutting closer margins. The industry must ask itself, are we doing enough to reinforce the aerodynamic limits these pilots face daily? And finally, it's worth reflecting on how we talk about experience. Experience is invaluable. It saves lives, prevents errors, builds confidence, but it can also create false security. The longer you do something without consequence, the more you believe you're immune from error. But aerodynamics isn't influenced by past success. It's binary. The wing is either flying or it's not. And once it's not, no amount of experience can bring it back in time. In the end, Gavin Morse's death was not the result of carelessness at all. It was a momentary misjudgment, made in a high-risk environment, during a routine operation he'd likely performed hundreds of times. That's what makes this accident so haunting, because it could happen to any agricultural pilot, on any day, in any field, and that's why we must talk about it, not to assign blame, but to learn, adapt, and prevent the next one. That's all for today's video. Thank you for tuning in, and don't forget to subscribe for more updates.